Hello again. This is session number 6. We're going to talk about sections and views. Um, so, first of all, it is common in engineering that components with internal features or hidden detail need to be defined. Um, so, there are two basic approaches to define hidden details in a component. The first one is to use hidden detail lines, those dashed lines that we've seen several times so far. And the second approach to use sections, where you can reveal the details that are hidden in the component. So in here, we're going to pretend that we cut through the object to reveal the internal components inside and to show the internal details of a component. The idea is that when we just pretend or imagine that we cut through a component, the saw that we use leaves some kind of marks, like saw marks, behind on the cutting section or cutting plane. And we just represent in our drawings those saw marks with what's called hatching, or those hatching in the section. Imagine here that we're going to cut through this part using a saw so that we can see the internal details of these two features. So after we imagine that we are cutting this component into two parts, we just imagine also that we remove this part here, and then we see only what is left. So after you cut this component into two parts, you just remove this part, and then you are left with only the part at the back here. And then you look from the front here, and you can draw the view where you can see the details of those features. So in here, for example, you have let's say this is the top view of the component on the previous slide. And then we use what's called the cutting plane line. And then we just again imagine that we are cutting through the component along this line. And then we get rid of the bottom part here. And then we try to plot the view here where we can see along this plane here to reveal the internal details or the hidden detail on the component. Normally for this we use arrows. We use two arrows on the left and right hand sides of the cutting plane line. And then the direction of the arrow here shows the direction of sight. So you cut along this line, then you remove this part, and then you look in this direction, and then you plot the part here. And you see these are the hatching of these areas, which is like similar to the saw marks that the saw leaves after cutting. And then we write underneath here section AA, so means that at this line here, cutting line, or what we see here, this section A is when we cut through the component using this cutting plane. So the direction of viewing, as I said, is shown by those two arrows with large heads. And we normally write capital letters near the arrows, like AA, for example, so that you just write here section AA. So whenever somebody reads the drawings, he or she understands that what you see here is the section at AA. When you cut through the component at AA, and then you remove this part and you look for in the same direction as the arrows, this is what you're going to see. And the same letter is used on the left and the right hand sides to identify the title. So you use the letters here AA, and also you write here section A. So a section view in general is used to clarify details, as we said. It reveals the internal details of a component. It shows internal features clearly, as you've seen on the previous slide. It was shown those two holes. It reduces the number of hidden detail lines, because otherwise we should draw like hidden lines if we're not using the section. It helps us to dimension the component, because it's not allowed to dimension like hidden lines. It also shows the cross section of the shape or of the component at this cutting line. And if we have an assembly and then you are given only the views without sections, so sections are used to just clarify the assembly, and you can see from inside how the components are assembled together, how they are related together, and so on. For example, here we have a cutting plane at AA. So if we imagine that we are cutting here in this direction, and imagine that you've removed this part and you are looking in the same direction as the arrows, then you can see the details of this component here. Otherwise, without section, it should have been shown with dashed lines. So it just clarifies the details here. So what we're going to see here is a section view in one plane. So you have these two are the same component, but here in one orthographic view, and here another orthographic view. Let's say this is the front view, this is the side view. Then using a single section plane, which is AA, if you imagine that you're cutting through the component along this line here, or this plane AA, you get rid of this part, and then you look from this direction, and then you will be able to see the internal details, which is like this slot that is going around. Also here, for example, you have another example where here the base here has like some cavity, but without using sections, it won't be possible to see this clearly. It will be shown using dashed lines, or it will be hidden. Also these two slots, it won't be like clear. But if we cut across here, these two holes, using sections, we'll be able to see the cavity here and these two holes as well. And then here you have section BB, here you have section AA, and you are able to see more clearly the detail, the hidden detail here. Sometimes we use what's called two parallel planes, and they are shown like as follows. Again, you have here the same component in two different views: the front view and the right hand side view. Then, if you just imagine that you are cutting across this plane first up until the center line, and then you are just cutting across this plane here. From here, just across up until the center line of the component. So just imagine that you have a saw, and then you are cutting across here up until this point, and then you cut across up until this point, and then you cut across up until this point. Then you get rid of this part, which is this part here, this part here, this part here. Anything on the left-hand side of this line and below, you just get rid of this part. Then the first plane shows you the internal details of this vertical part, and then the second plane shows you the internal detail of this part. Why we had to use like two parallel planes here? Because actually, if you use a single plane, you're going to cut across like this, and then you won't be able to see the details of this part. You would have only seen the details of this part, and here you could have seen this going all around. So if the one feature is shifted from the cutting plane, you still can use these like two parallel planes so that you can, in one section only, you can see the internal details here and there as well. In addition, you can even use three planes if necessary. So here the section view shows like three adjoining planes to show the true shape of this inclined surface. So for example, this is the front view and this is the section DD. So you can just imagine you have one plane, then the second plane, then the third plane, and then you had to go along these like kind of three planes, adjoining planes, so that when you get rid of this bottom part and you look in the same direction as the arrows here, you will be able to see the true shape or the internal detail of this component clearly. You'll be able to see the slot, what is happening here. You'll be able to see this internal detail as well. Exceptions of general rules of sectioning. Reps and webs, we don't like section through webs, especially when they are parallel to the cutting plane. We do not show sections for shafts, for rods, for spindles, for bolts, for nuts, for thin washers, rivets, dowels, pins, and cutters. All these things, like when we have a section, we show them without sectioning, without hatching, actually. So for example, here you have this bolt, and then you have the nut, you have the washer here. Though we have a section, but we haven't shown any sections across these. This web here, this part here is parallel to the cutting plane, so that we don't show any sections here for this web. For this shaft, for example, and this key here, we don't show like any sections or any hatching. So we just show the part as it is. Though here, when we cut across this one, if you look at the reps here on the left and the right hand sides, this is where they show in the section. So you have to be careful with this, because if the cutting plane is parallel to the web, so we don't like section it. But if it is perpendicular to the web, we have to section it. And if you imagine here, you have two webs. They are perpendicular to one another. One is here. This is the web in the middle, or let's say at the back. So you have cylinder here. You have another cylinder here. And then these two cylinders are connected together with this web. And they are connected together also with these two side webs. The two side webs and this web are 90 degrees to each other. When you cut across here, and then you get rid of this left part, and then you look from here, so you see that the section goes through this part, and then it will go from here to here, and then across this cylinder here. So for the left and the right hand side webs, because it just goes all across at the here at the back. So we are cutting at the cross section of these left and right hand side webs. So that's why it shows here. But for this web in the middle, the cutting line is, or the cutting plane is parallel to the plane of this web, so that it doesn't show, the section doesn't show for this one. So in short, there are some exceptions for sectioning, but for the web especially, if the cutting plane is parallel, so we don't show it we don't hatch it. But if the cutting plane is perpendicular to the web, we show the section. You see, for example, here, these are like different views for the same component. Then if this is the one view, and then you are cutting across here, then you are getting rid of this part. See here, the cutting plane the cutting plane here is parallel to the plane of the web. So in this case, see, the web here is not section, and this is correct representation. But here, if you just section across the web, so this is not correct. On the other hand, if you just imagine that you are cutting here at this section, and then you are getting rid of this part, then from here till here, you are cutting, the cutting plane here is perpendicular to the web. So that's why we just show it in the section here. So I think this makes it even more clear now. As we said earlier, that sections, they show the details of assembly drawings, they make it clearer. So for example, here we have like a pulley, and then this pulley is assembled together with this bracket here using the bolt and the washer and the nut, and there is one shaft here assembled with like this key. So when you cut across this, see, for example, here, because the cutting plane is parallel to the web here, so we don't like section this part. To spin the shaft here, and the shaft and the key are not sectioned. The bolt, the washer, the nut are not sectioned as well. So the web here and the web here, they are not sectioned. Sometimes they show here like only the cross section, just to show here that this is like a rod with a cross sectional area, circular cross sectional area. Sometimes also, if the scale that we use for a particular drawing is small, and there are some details that you cannot see clearly in your view. So what you can do, you can just enlarge a specific area. For example, here, if the details of this part here is not like shown clearly, you wanted to show the fillets, for example, and so on. So what you can do, you can just make like, you can enlarge this area. You can just add a circle here, and then redraw this part again here, using a larger scale. So the scale here is 5:1, so this is 5 times larger than this scale. And then using this kind of detailed view, you will be able to see more details in here. In SolidWorks and Fusion 360, this is done just simply, you just define the area and define the scale, and it will do this for you. So for hatching, there are some rules for hatching or for sectioning. You see here for these 3 different figures. The top one, if you just imagine that you are having here a tube, for example, and then you are cutting through the tube, and then you're just showing the section through the tube, so you will be able to see the top thickness of the tube and the bottom thickness of the tube, and then we show the saw marks by hatching here. So because the top part and the bottom part here are the same for the same component, so when we use hatching to represent this section, they go in the same direction. So the hatching here at the top, the hatching at the bottom, they go in the same direction. And when we see this in the drawings, when we read the drawings, we understand that this is the same component. The saw here is cutting the component at 2 different places. If you have 2 parts adjacent together, this will be more obvious when you have assembly drawings. So what you can do here, you can just flip the direction. So here, normally we use an angle for hatching of 45 degrees or 135 degrees. So for example, here for the internal part, you can use hatching of like 45 degrees and then for the other part, you can use 135 degrees. And also it will be like kind of staggered. You can just shift it a little bit from one another, as shown here. If you have more than two parts adjacent together, what you can do, um, you have different, we have different techniques. First, we think about like changing the angle or changing the spacing of those hatching lines. So if we stagger them as well. We use staggering. We just shift one from the other one. For example, if you look at these two, you see that the hatching of the part is the inside, the internal part here, and this adapter here. The lines are not like continuous. They are staggered together. Though they are in the same direction, but they are staggered, and this shows us that these two are two different components. And for this part, the angle here is different, 135 degrees. If you have a large part, you don't need to hatch the entire part. You can just only just show it like this. For example, this part, you can just show some part only. You hatch it. You don't need to hatch it entirely. There is one way of choosing this kind of hatching in those CAD software. We've seen this before. I think this is just to show that it is drawn according to the third angle projection, where you look from here along the arrows and you draw here on the right hand side, and this is section A to show the details of this part here. So for screws, there are some rules for hatching or for sectioning the screws. If you look here, for example, you see some details here, but you need to be aware of these details first. If you think about how this part is manufactured, so we use first a drill tab to make a hole, and then we use like different tool to make the thread, and then after that, even when we assemble the thread here, this part to this part, the thread of the bolt doesn't go all the way down to the end of the thread that you have made in the hole. So in this case, these two lines, it shows you the end of the thread for the bolt. This line here shows you the end of the thread in the hole itself, and this angle here shows you the tap of the drilling tip that was used for drilling the initial hole before the threading. When we assemble like internal and external threads together, you see here, so the two lines, we draw only two lines. So here, for this part, for the hole here, we have two lines, which shows the internal thread. And when we assemble this part together with this part, we have external thread for the bolt. But when we put these two together, the internal thread for the hole, which is for this part, and the external thread for the bolt, they go together along the same line. When we show the hatching, see the hatching ends at this solid line. So for the drill tab, we have a solid line. For the external part of the thread here, we have a solid line, so the hatching always stops at those points. And for the internal thread, the solid line is in the inside one, the internal one, and the light one, the light line is at the outside. And you can see here also that when these two parts assemble together, this part has like external, this part has external thread, this part has internal thread, but when they go together, they are aligned to one another. And always the hatching stops at the solid line or the thicker line. For example, here you have this stud or this bolt. Then without any sections, this is what you can see. If you look from the outside, you have a threaded part here on the right hand side, another threaded part here on the left hand side. When you look from this view, you can see two circles, and this is the convention for drawing the cross section or the circles for the thread. The external one, the external part here, or the external diameter, is shown with a complete circle, and the internal one is shown here with like 3/4 of a circle. But if you cut across this part, you have a section, so you will eventually understand that there are some details inside that you couldn't see, which is these two, which is this internal feature here. Again, when you use hatching here, so the hatching always stops at the thicker line, which is for external thread, it's the external line, and for internal thread, it is the internal line. You see here, because this is internal thread, so you see here how it is shown. The solid circle is the smaller one, and the 3/4 thin circle is the outside one. And then if you just imagine that you are cutting across this part here, and then you are looking from the left hand side, just to show the left hand side here, or to show the section. So you see here that the hatching line stops at the thicker circle, which is the smaller one for the internal view. If you are cutting across this part here, you are removing the top part and you are looking from the top, and then you can see the details because it's hidden here. But if you wanted to show this in a section, so you can just have a section line here, and then you can see the details more easily, and you can dimension them and so on. And because this is internal thread, so the hatching line stops at the thicker line here, which is the internal one for internal thread. The same for this one. It shows like that this thread is going through the part from one side to another, but this one has a specific depth and it stops there. But this one, it has a thread all across the part. Some notes here as well for you to read about the conventions for screw threads. We've seen this on the previous slide, but more details here. So hatching lines should be equally spaced. Normally you start by 4 millimeter apart. Hatching lines preferably drawn at 45 degrees or 135 degrees to the horizontal. They normally touch the outline. See here, for example, this line, and then the hatching starts at one outline and ends at the other. Then hatching lines should be inclined the same way for separate faces of a common component. So for this is what a single component, so the hatching that is used for this part of the component should be exactly the same as the hatching that is used for this second part of the component. So if we have different components like assembled together, what we can do, we can just either switch the angle. So we, for example, here we can just change the distancing. So here the distance here is large compared to here, so we can change the distance between these two. Or we can use 45 degrees here and 135 degrees here, for example. If you have more than two components, they adjacent to one another, as I said, we can just change the spacing. We can use different angles like 45 degrees, 135 degrees. We can stagger them as well so that they are not like this one and this one, they are not like meeting at this point. This line and this line, they are not meeting at this point, so we should stagger them to show that they are different components. These two parts are having the same direction of hatching, they are having the same spacing. So from the first look, you say like this is one part, these two are the same. So this is the second part, these two are the same, this is the third part. And that is the end of session number 6.